Welcome everyone to this week's
Hello.
Learning Space. Hi, my name is Nicole Gugliucci. I am a postdoc with CosmoQuest, and I am joined today by our formal education lead, Georgia Bracey,
Hello. Hi.
and our curriculum developer, Ellen Reilly. Hello, everybody. So this week we wanted to talk about a couple of things, mainly the NSTA conference. We just came back from in San Antonio. It's the National Science Teachers Association. Talk about some of the interesting, cool stuff we presented and or saw there at the conference. I have lots of pictures of animals. It's so cute. And talk a little bit about the next-gen science standards. Those standards were released the night before we flew out for the conference, something somewhat crazy like that. So somewhat ridiculous. But yeah, so we'll talk a little bit about that and how that impacted things at NSTA, and show off our swag a little bit. First, instead of a hands-on demo, I would like to share a cool, interesting TV show that I learned about at NSTA. It's called Sci Girls. Here's a little bookmark they gave me. So it's pbskids.org/scigirls, and it is a show geared towards getting girls interested in science. And I popped over to the website and was very excited that everything wasn't pink. Not that I have anything against pink, obviously, but so much of what you see for let's get girls interested in science is a little overly pink. So here's the website. This is what the website looks like, and I was all excited because there's a penguin in the truck. But it's a PBS series. They have games and stuff on their website, so I encourage you to check that out.
Are they targeting a certain age with that, Nicole? Can you tell? I don't know.
I want to say elementary, maybe into middle school.
It looked, yeah.
Yeah. I know the actresses that they have in there are kind of junior high age. That do the voices and whatnot. So yeah, check that out. Sci Girls. I have a little Sci Girl pin that they gave me as well. It's got a ruler on it, but it's not in metric. Wait, it is metric. Yay, metric ruler on it. Ah, awesome. So instead of a hands-on activity, I would encourage you to go play on their website and check out their show. So that's all I have for that. Man, not sure where to start.
Start with what you guys did down at NSTA, because I still haven't heard all the fun details. But who went and what kinds of things you guys were presenting? How many times? 6, 7, 8 different venues and things. So start there.
Okay. Yeah. So we did a bunch of sessions on Terra Luna, which is our curriculum that we've developed to go along with the Moon Mappers website and Citizen Science Project. And so that's a middle school level unit that Ellen and Kathy Costello have developed along with Georgia. And I threw something at it too, I think. That kind of worked.
Something very good.
And so yeah, we presented that. We shared it at a couple of sessions. They did a NSTA share-a-thon. That's the National Earth Science Teachers Association. Yeah, we shared it there. We shared it with the NASA wavelength session. We did our own session. So what we did was we did the crater activity, which involves, I don't know if you've ever seen us do this on the Hangout before, but it involves blasting a pan full of flour and cocoa powder with some kind of projectile. And I got some really great video of our workshop participants just blowing cocoa powder all over the place with their asteroid impacts. So I'll put that together at some point. Let me pull up a picture if I can. Yeah, this is the table covered in cocoa powder. It's ejecta all the way down, you guys. There's just cocoa powder everywhere, all over people's clothing.
That is a nice-size crater.
Yeah, that was probably the tallest drop.
Beautiful.
I believe that was the golf ball from 2 meters and with a little velocity. There was some velocity in that one. So
yeah, they got super into that. We didn't go fully through the measuring process, but we wanted to give them an idea, and they could immediately tell the differences that the velocity and the height would show, how you'd probably want a bigger pan than that in your classrooms, so you can actually count up the ejecta rates and they don't go across the table or the floor or whatever you're doing there. I want to pause real quick because I always forget to say this. If you want to comment or question on what we're talking about, there are several places you can do that. If you are watching on the YouTube channel, you can check that. You can leave a comment there. If you're watching on Google Plus on the event page, you can comment there. I see Andrew is commenting at us. Hello. If you're watching anywhere else on Google Plus, we should get that as well, as I've hit all the shared sources, I think. And if you're watching somewhere else and want to comment or question, use the hashtag #LearningSpace on Twitter. So you can reach us any of those ways. Oh gosh, what else did we do?
Okay, so you gave a talk.
I gave a talk.
Right.
I gave a pretty standard, here's what citizen science is and here's how you can use it in your classroom, and just gave them an overview of the Terra Luna unit. So the Terra Luna unit being a 3-week, I think with assessment it's like 3 weeks.
It's 3 weeks.
Right, okay.
Approximately 3 weeks.
You go all the way through.
Yeah.
Well, ultimately, it would be wonderful to be able to go all the way through. However, if you don't have that amount of time, you can pick and choose activities that you think would be more meaningful or most meaningful for your students. And we've arranged it that way: pre-tests, post-tests, quizzes, other assessments, and you can look at those tests, and if you've only done a few units, you can pick and choose the questions you would like to use from those tests that we've already prepared, or prepare your own.
Yep. And here's another activity I have a picture of. We had one called Earth or Not Earth. And this is how you start off your unit by giving your students a bunch of black and white images from the Earth and the Moon. Hang on, the screen share button went away. There you are. So again, thank you to our lovely participants, all of who gave me permission to use their pictures and video on the intertubes. This is, so we give them a bunch of black and white images and, ask them to decide, is that the Earth or is that the Moon? You can expand it if you were doing a whole planetary science thing, but we're sticking with Earth and Moon for this unit. And even at the table, the teachers got really competitive, but who was getting the right answers and actually sorting them properly.
Yeah, and the neat thing is that it also encourages students to back up their choices with some good reasons and arguments. So there's a lot of scientific discussion that ends up happening. And I don't know if you guys heard any of that with the teachers, where
we
they
did.
given some good reasons.
We did actually, which is what I was actually looking for, and it gives you an idea with your students how much prior knowledge they have. What do they see in that picture? One of the teachers said, "I think that's Earth because I'm thinking that that's snow on the top," and it was. And we had a big discussion about whether to include that photo for students, and I thought, yes, we need to, because I'm looking for a student to make that observation. And because that means that they're observing, they're really looking closely, and then they have a reason to give. I think this is Earth because, not I think this is Earth because. Well, although it might be okay to say this is the Barringer crater, I know because I was there with my parents, and that would be okay.
A lot of people will say, "Oh wait, I've been there."
I've been there, and that's okay too, because then you have some, they do have some prior knowledge. So we chose those pictures for reasons. Some of them are not easy. Teachers did not get them all right, even considering that they've been teaching earth science and space science. They would get a couple wrong, and that was interesting. They didn't like getting them wrong either.
But I think they liked learning something from that.
They did, and we actually used that at some of the other sessions, the share-a-thons, or when we were standing by the table. People were fascinated by that activity. They would flip the pictures up, because we do have the answers on the back. And they would try to put them in piles first and then flip them over. Everybody was into that one. Very simple, good activity to engage your students right off the bat.
And then we also took them through the mapping, the crater age activity that we came up with along with the Moon Mappers Lunar Scientists. And at the end of that activity, which is, I think it's a 2-day activity really, you have your students marking craters on black and white images of the moon. Well, black and white to save on ink doesn't really matter. But you have them mark craters on the moon with a marker, and then count how many craters are in each image. You put them together to make a larger picture, and used the crater counts to determine the relative age of the surface. And so you actually see there's somewhat of a gradient happening here between a surface that has fewer craters to a surface that has more craters. And so we did that twice, I think. We had one group do it, and then we had the other group correct them, correct their craters, because the first group was a bit rushed for time.
And both groups thoroughly enjoyed it. It was an activity that none of them had seen before, because it's
because we made it up. We pulled it out of our noses.
Like and the picture activity they had not seen before either, because that's another one we made up. So yeah.
So that was all of our stuff, pretty much. Unless I'm missing something, Ellen?
We did do a cafe.
We did do a cafe.
Did a cafe format. We had envisioned that people would show up, and just like in Paris when Hemingway and all of his intelligent people were hanging around and drinking wine and discussing wonderful ideas, we thought we would get them no wine, but get them discussing wonderful ideas about science, the challenges about teaching science, the kind of technology they had available in the classroom, how much they could engage their kids with technology, what citizen science had they done, share websites they'd used, and we had the papers covering the tables with markers so they could write on the tables like they were in a cafe. And sadly, we did not get enough people to really make this a meaningful session, because you really need to have several tables and have a, throw out a question and have them share their ideas, and have a report after 10 minutes, have a reporter from each table share what their table has come up with. We had one table with a few people that were having a good discussion, but it just really did not turn out the way we had envisioned.
Yeah, but Ellen, you totally wore the awesomest
hat. But I did. Oh, you and there I am.
And there you are with the coolest hat.
So somebody came up to me and said, "I want to see who the Harry Potter lady is." Well, actually, when I was teaching, I did use that as a sorting hat in my classroom for the lab group.
Okay.
That's a great picture. I hadn't seen that one.
You hadn't seen me either.
I haven't seen any of these pictures
First time for me.
Oh, they haven't been posted yet. This is my iPhoto library. I just uploaded them yesterday.
Nicole got them all.
Oh, yeah.
I do have them all. So in addition,
a small group though at NSTA. Maybe talk about the scope of the event, because I don't know how many even teachers get to the national conference, and there's just so much. Yeah.
And I was going to address that where the cafe was concerned too. There are between 15 and 20,000 teachers at this conference on any given day, because while it lasts 4 days, some come in for the entire conference, some come in for 2 days, some come in for 1 day, depending upon when their schools will release them. And there are a lot of sessions held. There's a lot to choose from. So I was disappointed with the cafe, but there was a lot to choose from at that particular time slot.
Everyone, and from what I've heard, that's standard for pretty much all those sessions like that. It's very rare to have one that's super crowded, because there is so much going on.
Very often the super crowded ones are the vendors, the ones that
give away free stuff
might do, and so on. And one of the reasons is that they give away lots of free stuff, and
sorry, we can't afford that. We gave you stickers.
And they can promote themselves.
Tribals.
And then there's the big expo hall too. Just all the booths. So a lot of times people are walking from booth to booth, looking at all the great stuff and getting all the free things they can carry and all that.
I got a little bit. I worked primarily at the NASA Science Mission Directorate booth, which of course, sadly, given sequester concerns, may not exist after this, which stinks because they just had a huge table full of educational resources for every grade level. So I picked up a cool poster that has some elementary school activities on the back. I picked up some information on a cloud citizen science project in Spanish. I got a New Horizons sticker from somebody. I don't remember who actually gave me that. And then a DVD, Journey to the Stars. So that was just a tiny sampling of all the stuff that they had just at that one table.
Yeah, so there's a lot of stuff to do and a lot of ways to spend your time. And that's probably just in the convention. I'm sure there's a few things to do outside the convention.
There are off-site things as well. I know that some of the SeaWorld is down there, and they did go to swim with the beluga, some people, and that could be tempting, whether you're a biology teacher or a science teacher. That might be a tempting thing to do for an afternoon. So.
Well, yeah, I mean, SeaWorld was right next to the NASA booth, so of course we were just having a blast. So I got to pet a flamingo.
Oh. You should match your hair color to that.
And I got to meet some penguins. Which has nothing to do with astronomy, but you're right. There are some attractions that you just can't resist.
But it's wonderful. And you know, about twice a day they walk them through it. A lemur.
Is that a lemur?
It's a lemur from Madagascar. Yes.
Sorry. Okay. No more animal pictures.
It's science. It's fine.
It's science.
So it's a great time. It's a great time.
Now, from what I understand from you guys, the ones on the East Coast are a little better attended because it's just the population density. You tend to get people that drive to these conferences because it's hard to get airfare or days off for teachers. And so if they can drive for a day, you get more people. And so the next one is in Boston next April. So there might be an actual, a larger crowd even for that.
Yeah.
But sorry, the abstract deadline was Monday.
Yeah, it comes up pretty fast.
Comes up really fast. Anything else particular at the meeting, Ellen, that struck you? Other than NGSS, because that gets its own.
Well, that is that's important. No, not really. You know, I will mention this. What I liked, I was sitting down once grabbing something to eat, and what I did find exciting is people would walk by and they were so excited about things. I mean, I was eavesdropping, imagine that, and I mean they were saying things like, well, when I went to this session, this is what they said, and I was able to make this volcano, or we had these DNA beads, and we were able to construct this, and these are the bits and pieces of conversation that I was getting, and I wanted so to be able to record it actually and show the public that teachers are here and they're working. Sure, they're having fun. Sure, they're on the boat in the river in the evening and so on. But they're also there because they're excited about science and excited about what they can learn and take home to their kids.
Yeah, there's so many great practical things that teachers can get at a conference like this, and they can go back and they can use it the next week in their class, which I know is what most teachers tend to want. They want those practical things that'll help them right away.
And they like picking up resources. Yeah, they like picking up, things they can do in the class. Like you said, the vendors giving away freebies. They like picking that up.
Because that's fun.
If I was a teacher, I totally would have done that. But I felt kind of bad. I feel like I shouldn't take things because I wouldn't actually use it except for my own enjoyment.
Oh, I had to refrain from that because I used to be a profession of that. I could leave with 30 pencils, enough for my whole class. But I did not do that this time. I did occasionally pick up something that I thought would be very good for my grandchildren because they are very good in science. Now,
education.
It's education. So.
I should point out I did get a mission patch from Project Mercury, not spelled the way you'd expect it to be. If you go to spacemicrobes.org, that's another citizen science project, but I got a mission patch from them, where they're sampling microbes all around, on the ISS and then also all around the world, and then they're doing this cool project. They've got several different science goals that they're reaching, and then they've got this one project where they're pitting microbes from different stadiums around the U.S. against each other in this like bracket sort of thing. I don't know how the sports ball works. On the International Space Station, so they're going to have microbes from stadiums fight it out in space. So yeah, anyway, they're also developing educational materials to go along with that. So go to spacemicrobes.org. That was a really fun presentation that I got to see.
For your microbe team. Great.
Yes, go root for your microbe team. How cool is that? I said this should totally replace the I mean, I love the Puppy Bowl, but I would love to see this be another Super Bowl alternative.
Try it. Yeah.
Microbe wars. Okay. So one of the big topics at NSTA was the NGSS. We're sitting in alphabet soup here. So maybe Ellen, you should give the overview of what is NGSS. I think you know better than Georgia or I.
NGSS is Next Generation Science Standards. And it's no secret that there have been science standards, and in every state, and many of them are different. And they're trying. The National Research Council got together to a couple, but 2009, 2010, to come up with a frameworks for different subject matters, including science. What do we think that children should know to be scientifically literate, essentially, not only to be prepared for college, but to be good citizens? What do they need to know to go out in the job, to go to college, be good at their jobs, to be responsible citizens who can vote on issues when they come up, because there are many scientific issues involving ecology and space travel and so on, and they have to vote on these things sometimes, and they have to vote for people who will vote on these things in Congress, and it's essential that they understand it. So they got together and made a framework of what they thought was essential. Then from the frameworks were finished about 2011, and then about 41 states contributed people to write the Next Generation Science Standards, and those from the frameworks. And you do not have to adopt them. I think approximately 26 states have adopted these, and they are linked to the core curriculum. They are linked to core. Or they are not current. They're not. If you pull them up right now, the
current draft, the current final draft, which is
it's coming. It's coming. So. What else can I tell you? They're basically the frameworks. Should we talk about the frameworks first?
Sure. How are they structured?
They're structured in 3 dimensions, and the first dimension is practices, which we used to call way back in the day process skills. The skills the kids they need to know to do science. The second dimension is cross-cutting concepts, and it's concepts that have application across all domains of science. And it's a different way of linking different domains of science, including patterns and similarities and diversity and cause and effect and things like that. Yep. And the third dimension is disciplinary core ideas. And basically, it focuses on the power of K-12 science curriculum instruction and assessments. It has a significance. It's supposed to appeal to the interests of the students, the experience of the students, and the thing that's important, and what the NGSS has taken from this, is that basically we need fewer topics and greater depth, because we can't teach all the facts. We just need, how can you know everything?
And you don't need to anymore.
You do need to know how to access them. You need to know enough to know the keywords, and you do need to know how to do the research to get your answers. But the process is very important, and it's very important for kids to be able to do inquiry. And years ago, what happened was, first they were reading it out of a book. Then the next thing was hands-on. We were all going to do hands-on things, and that was great. But hands-on had essentially an answer. We were giving them the problem, and we knew what the answer was going to be. Now the next step, and we started this maybe 15 years ago, so it's it was kind of surprising to me that they still are insisting that, oh my gosh, this is a brand new thing, and that teachers aren't doing it, because I think a lot of teachers are doing it. But the next step was inquiry, and that is, let's have the kids ask a question and answer, and then go through the process of designing an experiment and answer it. How would I answer this question? Just like a scientist. Have them be real scientists, because this is a skill not only used in science, it's used in everyday life. It's a problem-solving skill. And it's a skill that's going to help them make decisions about their life, not just science. And so this is the whole thinking behind Next Generation Science Standards. So if anybody want to jump in here, anyone, have I kind of given a good background of what the whole
my understanding is that there's 26 states that have decided they're going to adopt it. at this point, but there is a lot of strong hope from the drafters of the standards that it will become a national movement over the next few decades. I think I have a little map here of the states that are leading it, the development, and it's a total checkerboard. I remember looking at this going, this doesn't make sense, doesn't make obvious political boundaries, it doesn't, hit obvious geographical boundaries, but as you guys pointed out to me, I think, this map follows along with a certain educational consortium that started the movement. So if you want a quick look, I grabbed this image. I need to point out, I grabbed this image from the Skeptical Teacher blog. Matt Lowry, who blogs on all kinds of science and skeptical topics, posted this image, which is where I first saw it. The blue states are the ones adopting the NGSS, and the white states are the ones that have not yet, depending on how optimistic you want to be.
And tell us the website. Do you have the NGSS? I think.
Yeah, it's nextgenscience.org, and I've put that up in the event comments, and I'll put it in the YouTube description at the end. So
find all of that stuff, plus download the standards themselves in a couple of different ways.
You can just Google NGSS. It'll take you there.
The website.
Yeah. So that'll give you all the details.
Also, I pulled something up this afternoon because I wanted to be able to maybe make some intelligent comment tonight. But no, more than that, I pulled it up because I was interested in the international community as well. And in developing this, there was a group called Achieve, and I'm not exactly sure which group that is, but they did an international study using 10 countries that are closely related to the United States, either because they are top scorers on international tests, or because they are closely allied to us. And the research showed that in 12 model countries, they have integrated science standards, which is what NGSS is doing. There actually is an emphasis on physical science and physics in all these countries. Interesting. And in the life sciences, they emphasize the social significance of life science, which I thought was interesting. All of these countries are into cross-cutting content that's common to all the sciences. And they emphasize the ability of students to plan and carry out an investigation, which is what this is about too. We're interested in content to a certain extent, but we're interested in inquiry, practice, and content as they go together. So they're also interested in making science available to all student populations. All student populations in these countries have access to science. So that's part of what they were thinking when they were putting the next gen standards together. And it sounded good to me.
Okay. And a lot of what I heard, we had a speaker here on campus talking about the next gen standards, is they heard the cry of teachers saying, we don't just want to teach facts, we want to teach inquiry, we want to do these kind of things. And so the standards were built towards that. And so that's a really positive thing for those of us who shake our fist wearily at the state of science education in the U.S. They're just teaching to facts in the test. These standards were built with that in mind. Let's teach how to do science. Now, of course, how to test that.
We know so much more now about how students learn science than they did 2 and 3 generations ago. We just know that children just remember it more if they can do it. We remember it more if we're doing it, if we're made to think about it. We're made to come up with a question ourselves, and then kind of makes sense. I mean, it seems obvious right now, but evidently it wasn't 2 generations ago, but it is rather obvious now. So.
Right. And there's a lot of engineering concepts that go into it as well. Speaking of
I was going to say that's kind of a new feature, and Ellen mentioned those disciplinary core ideas. So there's 4 of them, and engineering, as well as technology and applied or applications of science, is one core idea, along with the life sciences and earth and space science and physical science. So you actually have engineering sort of rising up and taking a pretty major, equal role or place in amongst all the other typical content for science. So the process of engineering as content itself is kind of a new thing. So, that's that's one of the things that I think a lot of teachers are wondering about is, this really is kind of new. I'm sure there was engineering here and there, but it's more predominant now with these standards. And so, and there's a lot of good stuff out there, though, to help teachers put some engineering into their curriculum. So, but that's a new thing.
Actually, that is very new. That is correct, because they used to distinguish that. Well, this is science, like pure science, and then the engineers take what the scientists discover and they just use it, they apply it. Well, now there's a new way of looking at that. It's, scientists do, or in the pure sciences, they come up with investigations and they investigate a problem, but the engineers have to also are presented with a problem, and then they have to come up with a design or model to solve that problem. So it is very integral. They're very closely related, and that is now recognized.
Yeah, that scientific thinking is key to both.
Exactly.
Yeah, they're really close. They're very much related.
So we're bringing, STEM is the buzzword these days, right? STEM. It's our new sticky notes. So we've got, math has its own standards, right? The core curriculum, right? This is part of the
core curriculum. They have their own standards, and they are definitely linked to Next Gen. I mean, it's there. You don't wait for it. It's right there right now.
And then now S has its own standards, and we're saying that T and E are being highly featured in the science standards. And so we're really bringing the whole STEM bit into the classroom.
And there are technology standards, and I have to admit, I kind of would think there's probably engineering of some sort for education out there, but I don't really know. I don't know, Ellen, if you're, but I know there's tech standards as well. So, there's a lot already out there, and that's, part of the struggle that teachers have is, there's so many standards in so many different places, and, what do you do? What do you do when you get to your class every day, and that, some of that is filtered through, and it comes down to the state, district, or local level as to how that all plays out in the classroom. But there is certainly, a whole lot of standards out there, and so now we have another set.
Well, yeah, and when you're as old as I am, you have been through several sets. As I say to people, I've been through IGAP, ISAT, I quit. So that's what happened to me. But not really.
You're still here.
I'm still here looking at. Quit. No, I don't ever quit. Here I am looking at more standards and excited.
Her retirement is creating curriculum for lovely people. I want to remind you guys, if you're watching, you can comment on YouTube, on Google+, anywhere this is broadcasting, and we will see your comments and questions. Also use the hashtag #LearningSpace on Twitter, and we'll see that as well. And feel free to share the link and share the video after it's posted with your teacher friends. I'd love to get more feedback. Speaking of feedback, Ellen, did you get a sense at the conference from other teachers, or do you both, from talking to people in general over the last couple years, get a sense of what teachers are doing to get ready for NGSS, or how they feel about it being implemented?
Well, the teachers that I've had conversation with mostly are the middle school teachers. That's where I taught. And they were caught up really in the core curriculum initially, with Next Gen being kind of a secondary thought for them. They knew it was coming. The ones that I have talked to are very excited about the inquiry. One actually was very sad because 2 years ago, because we've been a little slow, let's face it, with the Next Gen. It was supposed to come out 2 years ago, and so because it did not come out, the core standards came out for science, and they were core standards for science literacy. So a lot of the schools then started putting pressure on the teachers to read, just read in science, because the core standards said there were basically literacy standards, and you read them, and my friends are saying, no, we have fought so hard to get inquiry in the classroom, we're going to sneak it in anyway. So now, of course, they don't have to sneak it in, it's going to be linked, and they're excited about that.
So the core standards, to clarify, are math and language arts, primarily? Okay, I put a link to that. That's just corestandards.org. Is that being adopted widely across the U.S., or is that similar in that it's like half and half, like NGSS?
my impression is that it's like half and half.
Okay.
It's like half and half as well, because there are some states that are just, they're looking at them very closely. There are issues with some of the things that are included in the core standards that the states may not believe should be taught, and so on, which is always the case. So that is a problem. And education in the United States is not federally controlled. I mean, we get federal input, we have grants and that kind of thing, but it is more, the control is more on a local level.
Well, that's why these are all .org websites, not .gov. I mean, these are independent boards of teachers and educators that have come together to come up with these standards.
And in fact, and when I pulled this up this afternoon, it said, and I'll just read you from it, it said, the creation of NGSS was entirely state-driven, with no federal funds or incentives to create or adopt the standards. So it is a statewide.
So even though we say U.S. standards, that's not at all. We have a comment from Ted Willard that says Common Core has been adopted by 46 states.
Wow.
That's almost 50.
That's almost 50.
That's
Yay! Well, that sounds good.
Awesome. So that's a much higher acceptance rate than we thought. Yeah, and hopefully, I mean, since they already, they do tie in to the NGSS when they're looking for science standards, hopefully they'll pick that up, because that allows you to cover both in a lot of ways. And I know the Terra Luna lesson plans you guys came up with all have links to the NGSS. They have some additional activities that hit Common Core, and then there are some other standards. I know there's internationally there's another set of standards that seems to be becoming popular.
Project 2061, that has been around for a long time, is used in the international community. These are benchmarks that have been set up, and it's 2061 after Halley's Comet. Is that comet? Is that how you?
Oh.
Yes, that's why it's 2061.
Do not know that.
That has been around for a while, and the international community is using it, so we did align it to that, and also National Science Education Standards, NSES. It is also aligned to that.
NSES is the U.S., right?
Yeah, that is U.S.
The current ones.
The whole idea is that, as I am retired from the classroom, but I know how much time it takes to teach, for me in middle school, maybe 130 kids a year, and interface with the students and the parents and so on. And you should align your curriculum to standards, and it takes a huge amount of time to look for them. So if you can present the teachers with curriculum that you can show them where it's already aligned, they are thrilled to get that. They don't have to go searching and proving that they are teaching to the standards.
Yeah, I have my friends in Virginia, Dark Skies Bright Kids, have been putting together activity lesson plans for hands-on astronomy activities, and Virginia is not one of the states adopting NGSS, so they've been aligning them to the Virginia standards of learning, the hilariously acronymed SOLs, and I think we're gonna we're gonna try and align those to the NGSS as well, so that we can reach more people, but. If more people adopt NGSS, it makes it a little easier to create these lesson plans. It can be used, anywhere. Make our jobs easier.
A lot easier.
But even a lot of Terra Luna was created before the standards actually were released. They were just released about a week ago. But the framework was there, and so currently, they are aligned with the framework, but we'll actually have to do a little more tweaking on Terra Luna. It's that now that the standards themselves are finally out after going through a couple of drafts and public comment, just to take another look and probably just add some details in there now that everything's finalized and out to the public. So
now I would like to add also that actually, sadly, there aren't as many standards for earth science and space science as I would like to see.
Yes.
There, and even less for space science than earth science. And that makes me sad.
And kids like space. I mean, come on.
You know what? I always tell people, hey, what are 3 things kids love? Dinosaurs, whales, and space.
Rockets.
I
TA'd a class in undergrad. It was a freshman seminar. It was about dinosaurs and rockets. It was basically, let's relive our favorite childhood things. We're going to talk about dinosaurs and rockets. And it was just the coolest class. That was college level. So yes.
I love
More
it.
dinosaurs, more space, and kids will love you.
Yeah.
I found the graphic of how many states have adopted the Common Core right on their website.
Fantastic.
Looks like they say 45 plus several
Wonderful.
territories. So the yellow have adopted Common Core in language arts and math. The orange have not. Virginia, come on!
Oh, look at that.
Spent 7 years living in you. What are you doing?
Alaska.
Yeah.
Gosh.
Alaska, Minnesota.
Minnesota.
We'll see.
Minnesota.
Nebraska.
Minnesota. I gotta say.
Goodness.
Minnesota.
Well, my daughter lives up there. I'm going to have to call her. Not that she. Say, why are you living in that state?
Yeah. So although the science standards have been on their way for quite a long time, really, and the districts and teachers know that they're coming, most people have been dealing with Common Core implementation just because that kind of got, that was first. That got there quicker. But they've known that this is coming with the new science standards, and in some way I heard a teacher say that, watching the adoption and what people are going through with Common Core has kind of paved the way for, what may happen in a way with next gen standards. So they've been, a lot of teachers and districts have been through an adoption process of a new set of standards, and maybe the new science standards will be a little easier.
Is that good or bad?
Well,
did it go well or not? I guess is the question.
It totally depends on where you're teaching at this point.
Okay.
But now that they're out, districts will take a more, serious look at the next gen standards, because they're here, finally here.
They exist.
The big question too is how they will be, how assessment will look with the standards.
Oh yeah.
So that is really still yet to come. There's lots of ideas and lots of things kind of in the works and going on with that, but the standards are one big step, but what the assessments are going to be that show how those standards are maybe implemented, that's a whole nother story.
I remember when I was in 4th grade, we had some state test in New York. And I don't remember much, except I remember they took us all down to the gym, and they had all these little experiments set up, and we had, a time limit at each one, and we had to do these little experiments and fill out little lab reports. Is that the kind of thing that we'd be moving to? We're moving away from bubble sheets and towards this little setup.
Well, ultimately, that would be a wonderful thing, and Illinois tried to do that with, I said IGAP, I was making a joke before, but IGAP standards did involve 2 dimensions. And the first dimension was content, the bubble, where you have to answer the content of the facts. And the second dimension that you were supposed to implement in your classroom and was going to be implemented on the statewide level was exactly that kind of thing, where you gave them a problem. For instance, you'd give them a ruler with a groove in it, a marble, and ask them how they could make that marble fall down, how they could make it go faster and farther and that kind of thing, and go for it. Write yourself a question, tell me the variables, what's your independent variable, what's your dependent variable. In other words, it was process.
Yeah.
And I was kind of excited about that, and I developed that all in my classroom, and I had everything, and not just me, we were all doing this in our classrooms, and it came time to present all of our data that we had collected to the state, and that's when they threw IGAP out. So that's why, and they said, no, we're having ISAT now. And one of the reasoning, frankly, it was expensive. In order to get people to score that, you have all these rubrics, and you have to have 3 people scoring usually. When you have an assessment like that, and it's expensive to pay these people to score these tests. And Illinois said, we can't do this.
Scantrons are cheaper.
Scantrons are much cheaper than trying to score this type of assessment. Now, you can do it in your classroom, though.
Yeah, you can do it in the classroom.
Absolutely do it in your classroom.
But where's the incentive to implement it in the classroom if their state tests are going to be bubble sheets? Yeah. Right? Well, that's the problem.
No incentive.
Well, for people who are passionate,
well, people who want to will figure out a way. Yes, that's true.
We say, okay, fine, and basically, and I have given workshops like this to teachers. They wanted to know how to do well on the science tests, the standardized test. And I said, I don't know the answers. I don't know the questions. I don't know the answers. I know a certain amount is content, a certain amount is process. But I can tell you this, if you teach good science, your kids will do well on those tests. Because even if you haven't taught that particular fact, if you get kids excited about science, then they're going to listen to NOVA. They're going to listen to Animal Planet. They're going to tune in to other science things. And so the facts that you weren't able to jam in their head because you didn't even know what to jam in their head, those they're going to know them because you made them excited about science. And if you do inquiry, they will be excited about science.
And the point is to not necessarily to create a new generation of scientists. Yes, we hope some fraction of them will become scientists, but not everybody is going to be interested at that level. But we want everyone to have that kind of scientific thinking and be able to navigate our modern society with that kind of knowledge and experience and process.
You're a problem solver.
Yeah.
You just learn problem solving skills.
Mm-hmm.
So NGSS, we're optimistic about this in general.
High hopes. Yeah.
I have high hopes.
Good.
Say that. Yeah.
Okay. I wanted to share something quickly, another resource. Since I spent 5 hours at the NASA table sharing this with people, I will share it with you guys. A little while ago, only a couple months ago, I think, they launched a new resource called NASA Wavelength. If you've ever gone to NASA looking for a lesson plan to go along with a certain subject, you may have gotten lost in a circle of Googling hell, trying to find something. Everything was everywhere and different projects at different sites. So now they have one website where all of the NASA-approved and NASA-funded products are listed. Actually, you can see this little picture here this picture here where they're featuring the NSTA 2013 resources. They actually have a picture from NSTA 2012 with Pamela and Georgia and Ellen and Kathy all at the NASA booth from that year. So.
Whoa.
Didn't know if you knew that. You guys are on the NASA Wavelength homepage this week.
That's really wild.
That is wild.
I was looking at that going, wait a second, they look familiar.
Okay, I actually noticed Pamela there, but I didn't, yeah.
Yeah. So, but okay, so that's the top story, is the resources that were all presented at that meeting, including Terra Luna. But you can, what's cool is you can search for resources by audience, by topic. You can enter a search term and filter by what grade level you're looking for, or you can just hover over these circles and it tells you how many resources are available at each grade level. So if you're a middle school teacher, there are 971 resources that you could choose from. 862 for high school, 789 for elementary school. So if you're a teacher looking to implement any of these activities in your classroom.
Multimedia down lower.
Yeah, they have apps, ScienceCast, Eclipse, cool. Images. Yeah, all kinds of images are in here, as well as lessons and activities. You could even do something that's not space related. You can type in biology. And apparently my internet's slow. There we go. 22 results on biology on a NASA website. So no matter what kind of science you teach, NASA Wavelength, they did a really good job with this website, making it easy to use. Oh wait, let me show one more thing. On the side here is once you search for your topic, you can actually look at how much time you have in the classroom that you want to spend on it. Do you have 30 minutes? Do you have 6 hours? How much is it going to cost you for all the materials? What are the levels? You can just, it's just really
instructional strategies.
Yeah, here we go. Hands-on learning, guided inquiry,
and more.
Wow, a whole lot.
That's
so they've really taken the time to comb through these things, and so it's a really and that's what we hear from teachers all the time is it needs to be easy to get to and simple, because I have like an hour a day or a week to gather all these materials and get them ready, or I have a limited amount of time on the computer at school to do this. And so they've made it really easy to search for what you're looking for. So kudos to NASA Wavelength. This is one reason why NASA education funding is so important.
Need to continue that.
Hint, hint, wink, wink.
Lots of good resources. And, so you guys were at NSTA, obviously, so I guess a little plug for NSTA with Next Gen. NSTA, along with Ellen mentioned Achieve earlier, those are some of the groups that have been really instrumental in getting the standards going. NSTA has tons of resources for understanding the Next Gen science standards, navigating your way through them, because while it's a very exciting set of standards, it's not simple. It's also very complex. So there's lots of free webinars, there's books, there's NSTA has tons of stuff. So that would be a place to start anyway. But as someone said earlier, you Google Next Gens and you get a lot of good stuff too. But NSTA has it all kind of nicely in one place.
They had a lot of sessions specifically on NGSS and understanding it. I know, Ellen, you and Kathy went to a couple of those, but you already knew all the basics. So.
Well, what they were like. We knew what they were going over, yeah.
Because you have been developing the Terra Luna curriculum. You were
why.
familiar with them.
We have been reading the different permutations of the standards and waiting, and then when we would go back to find them, they were gone. Because
I know.
they're gone. Oh, we took them away.
Yeah, they put the drafts out there for a while, teasing you, and then, oh, now we're done. And
I know, I emailed Georgia going, where's the last draft? It's not on the website anymore.
To wait for the next release.
Yeah.
So, yeah, it'll be really interesting as we go through. And
But teachers who are in the classroom right now don't have the time to peruse through draft after draft of the standards, so it's good that they have that introduction there at NSTA. And there are other regional conferences as well. Actually, there's a STEM Expo happening in St. Louis in May 17th-ish.
That sounds right. I think that's a Friday.
It's the weekend I'm not here. One of the weekends.
15, 16, 17 of May in St. Louis.
In St. Louis, so local to
another
us.
Opportunity, but there's lots of local.
Portland, Charlotte, and Denver are the next three.
So again, on the NSTA site, you can get all that information.
So yay, fun.
So there
my first NSTA conference, I had a lot of fun. If I was actually a teacher in the classroom, I would have had so much more fun collecting all the cool things, and that's fine. I came to present. I did my duty. So
it's hard for those of us who have switched sides, because I would read through and I'd say, oh, that would be wonderful. I could go there and I could learn to do this, and then I could take it back to, nope, I don't have a classroom now, so that's not going to work. So
yes, I've got some students that this would be great. Well, no, not anymore.
Not anymore. So.
Well, Kathy at least had her student teachers to bring things to, so she packed her suitcase full of things for them.
She did. Yes.
So, and then you guys, because I forgot which of the companies had like the bugs and creepy crawlies, and there was this tarantula that was so fuzzy and cute. I wanted to.
Oh, Carolina Biological and Nicole.
Carolina.
Yeah, and we said, the last day they don't bring those back with them; they give them away. And
do they really?
Yes. And Nicole said, "Well, like I'm going to get that on the airplane." And so we gave her a present.
A present! Yay. Well, I need someone to identify this for me. Bug Girl, if you're watching, what is this? I know you hate that question, but it's really cool, and it's a paperweight. And
what's his name?
I don't know. I haven't come up with a name yet.
Her?
Or her. I don't know. We'll have to think of something. So, creepy crawlies. Thank you, Ellen and Kathy. You guys are
You're welcome.
Is there any last thoughts? We're coming up on an hour. Any last thoughts that you have on the meeting itself or the science standards?
We're going to see how they go with assessment. That's my real interest. And I think we'll definitely come back and revisit NGSS, just a whole topic.
We'll try and get, maybe we'll try and get someone.
There really is. There's a whole lot more. They are very complex, but lots of good stuff. And a lot of teachers are already doing exactly what the NGSS would like to see all teachers and all students doing. So for a lot of people, it's not new, but for a lot of people, it is. And we'll be back to talk more about it because it's really complicated.
if you have been involved in the NGSS process and would like to be on our show, email educate@cosmoquest.org. Actually, I have at least one person in mind that we should invite to come talk about it, because that would be really cool to hear it from the authors themselves.
If there's a writer out there listening to us who would like to share, that would be wonderful.
Yes. All right, I think that's it for today's show. Thank you for watching Learning Space. Our next Google Hangout today is Wednesday. Our next Hangout is Thursday, tomorrow at noon Pacific. The Planetary Society do their Hangout on air. And then at noon Pacific on Friday, we do the weekly Space Hangout. And we will be covering topics such as, did we find dark matter again, maybe? Can we capture an asteroid? And we will certainly cover the exoplanet news that is embargoed that will come out tomorrow. We'll talk about that on Friday. So stay tuned for that. And yeah, that's our show. Captain Chuck.
Okay.
Also went to NSTA, says hello. I'm Captain Chuck. People love the squirrel. So yeah. All right. Thank you. Thank you for joining me.
Thank you. Thanks, Nicole. Thanks, Ellen.
Thank you.
We'll see you soon.
Bye.
Bye.
Here's another activity I have a picture of. We had one called Earth or Not Earth. And this is how you start off your unit by giving your students a bunch of black and white images from the Earth and the Moon. Hang on, the screen share button went away. There you are. So again, thank you to our lovely participants, all of who gave me permission to use their pictures and video on the intertubes. But this is, so we give them a bunch of black and white images and, ask them to decide, is that the Earth or is that the Moon? You can expand it if you were doing a whole planetary science thing, but we're sticking with Earth and Moon for this unit. And even at the table, the teachers got really competitive, but who was getting the right answers and actually sorting them properly.
Yeah, and the neat thing is that it also encourages students to back up their choices with some good reasons and arguments. So there's a lot of scientific discussion that ends up happening. And I don't know if you guys heard any of that with the teachers, where
we
they
did.
given some good reasons.
We did actually, which is what I was actually looking for, and it gives you an idea with your students how much prior knowledge they have. What are they?
Yes.
What do they see in that picture? One of the teachers said, I think that's Earth because I'm thinking that that's snow on the top, and it was. And we had a big discussion about whether to include that photo for students, and I thought, yes, we need to, because I'm looking for a student to make that observation, and because that means that they're observing, they're really looking closely, and then they have a reason to give. I think this is Earth because.
At the website, this is what the website looks like, and I was all excited because there's a penguin! In the truck. But it's a PBS series. They have games and stuff on their website, so I encourage you to check that out.
Are they targeting a certain age with that, Nicole? Can you tell? I don't know.
I want to say elementary, maybe into middle school.
It looked, yeah.
Yeah. I know the actresses that they have in there are kind of junior high age. That do the voices and whatnot. So yeah. Check that out. Sci Girls. I have a little Sci Girl pin that they gave me as well. It's got a ruler on it, but it's not in metric. Wait, it is metric. Yay, metric ruler on it. Ah, awesome. So instead of a hands-on activity, I would encourage you to go play on their website and check out their show. So that's all I have for that. Man, not sure where to start.
Start with what you guys did down at NSTA, because I still haven't heard all the fun details, but who went and what kinds of things you guys were presenting, how many times? 6, 7, 8 different venues and things, so start there.
Okay. Yeah. So we did a bunch of sessions on Terra Luna, which is our curriculum that we've developed to go along with the Moon Mappers website and Citizen Science Project. And so that's a middle school level unit that Ellen and Kathy Costello have developed along with Georgia, and I threw something at it too, I think. That kind of worked.
Something's
right. The floor, whatever you're doing there. I want to pause real quick because I always forget to say this. If you want to comment or question on what we're talking about, there are several places you can do that. If you are watching on the YouTube channel, you can check that. You can leave a comment there. If you're watching on Google Plus on the event page, you can comment there. I see Andrew is commenting at us. Hello. If you're watching anywhere else on Google Plus, we should get that as well, as I've hit all the shared sources, I think. And if you're watching somewhere else and want to comment or question, use the hashtag #LearningSpace on Twitter. So you can reach us any of those ways. Oh gosh, what else did we do?
Okay, so you gave a talk.
I gave a talk.
Right.
I gave a pretty standard, here's what citizen science is and here's how you can use it in your classroom, and just gave them an overview of the Terra Luna unit. So the Terra Luna unit being a 3-week, I think with assessment it's like 3 weeks.
It's 3 weeks.
Right, okay.
Approximately 3 weeks. You go all the way through.
Yeah.
Well, ultimately, it would be wonderful to be able to go all the way through. However, if you don't have that amount of time, you can pick and choose activities that you think would be more meaningful or most meaningful for your students. And we've arranged it that way. Pre-tests, post-tests, quizzes, other assessments, and you can look at those tests, and if you've only done a few units, you can pick and choose the questions you would like to use from those tests that we've already prepared, or prepare your own.
Yep. And welcome everyone to this week's Learning Space. Hi, my name is Nicole Gugliucci. I am a postdoc with CosmoQuest, and I am joined today by our formal education lead, Georgia Bracey.
Hello. Hi.
And our curriculum developer, Ellen Reilly. Hello, everybody. So this week we wanted to talk about a couple things, mainly the NSTA conference. We just came back from in San Antonio. It's the National Science Teachers Association. Talk about some of the interesting, cool stuff we presented and or saw there at the conference. I have lots of pictures of animals. It's so cute. And talk a little bit about the next-gen science standards. Those standards were released the night before we flew out for the conference, something somewhat crazy like that. So somewhat ridiculous. But yeah, so we'll talk a little bit about that and how that impacted things at NSTA, and show off our swag a little bit. First, instead of a hands-on demo, I would like to share a cool, interesting TV show that I learned about at NSTA. It's called Sci Girls. Here's a little bookmark they gave me. So it's pbskids.org/scigirls, and it is a show geared towards getting girls interested in science. And I popped over to the website and was very excited that everything wasn't pink. Not that I have anything against pink, obviously, but so much of what you see for let's get girls interested in science is a little overly pink. So here's the...
Very good.
And so yeah, we presented that. We shared it at a couple of sessions. They did a NSTA share-a-thon. That's the National Earth Science Teachers Association. Yeah, we shared it there. We shared it with the NASA wavelength session. We did our own session. So what we did was we did the crater activity, which involves, I don't know if you've ever seen us do this on the Hangout before, but it involves blasting a pan full of flour and cocoa powder with some kind of projectile. And I got some really great video of our workshop participants just blowing cocoa powder all over the place with their asteroid impacts. So I'll put that together at some point. Let me pull up a picture if I can. Yeah, this is the table covered in cocoa powder. It's ejecta all the way down, you guys. There's just cocoa powder everywhere, all over people's clothing.
That is a nice-sized crater.
Yeah, that was probably the tallest drop.
I believe that was the golf ball from 2 meters and with a little velocity. There was some velocity in that one. So
yeah, they got super into that. We didn't go fully through the measuring process, but we wanted to give them an idea, and they could immediately tell the differences that the velocity and the height would show. How you'd probably want a bigger pan than that in your classrooms, so you can actually count up the ejecta rays, and they don't go across the table